For this problem, we want to solve with the quadratic formula given 6x squared equals 2x plus 1. In order to solve using the quadratic formula, we must first have every term on one side of the equation equal to 0. So, let's go ahead and move everything to the left side of this equation. It would be perfectly okay to move it to the right, but in general you want to keep the x squared term positive for ease of simplifying later on. So to move these over, we're going to subtract 2x from each side, and then subtract 1 from each side, giving us 6x squared minus 2x minus 1 equals 0. Once we get to this step, we can start talking about the quadratic formula. So the quadratic formula says if you're given a problem of the form ax squared plus bx plus c equals 0 for any a, b, and c except when a equals 0, then this will always be solved using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. While this may seem like a very long and complicated formula to commit to memory, it actually turns out that using this formula, although as complicated as it may look, will simplify the problem of having to factor or use the square root property or completing the square by quite a bit, as it removes all the algebra and just turns this into an arithmetic problem. So with this in mind, let's go ahead and write out our a, b, and c. We have a is equal to the number in front of x squared, which is 6. B is equal to the number in front of x, which is negative 2. And c is the number that's by itself, which is negative 1. So from here, plugging these into our formula, we have x equals negative b. So that's negative 2, since b was negative, plus or minus the square root of b squared, so that's the quantity of negative 2 squared, minus 4 times a is 6, times c is negative 1, all over 2 times a is 2 times 6. Which gives us x equals negative 2 means positive 2, plus or minus the square root of negative 2 squared is positive 4, minus 4 times 6 times negative 1. Well, the negatives are going to become positive when we multiply them together, and 4 times 6 times 1 is just 24. And that's all over 2 times 6, which is 12. So we continue simplifying. We get 2 plus or minus the square root of 28 over 12, which gives us 2 plus or minus, and the square root of 28, if we move this off to the side, remember you can break up a square root into 2 different square roots being multiplied together. So the square root of 28 has a perfect square in it, the square root of 4. And if we multiply that by the square root of 7, that's the same thing as the square root of 28. But we do this because the square root of 4 simplifies down to 2 times the square root of 7 instead of that square root of 4. So 2 plus or minus the square root of 28 is the same thing as 2 plus or minus 2 times the square root of 7 all over 12. And now, at this point, we can factor out a 2 from the top, since we are adding and subtracting, which gives us 2 times 1 plus or minus 1 times the square root of 7, or just the square root of 7, all over 12. And now notice we have a factor of 2 in the top and bottom. We can cancel that out, leaving us with a 6 in the bottom. So we're finally left with x equals 1 plus or minus the square root of 7 all over 6. And these are the two solutions to our original problem. 1 plus the square root of 7 all over 6, and 1 minus the square root of 7 all over 6.